Okay, good morning, Professor David De Los Reyes. Okay, I will be having a long video format for decision. Okay, my topic for decision will be area of an oblique triangle. Oblique. The last time around, I derived the formula on how to take the area of a right triangle. The area of a right triangle is actually 1/2 base times height. That was the last time around, my other long video format. Okay, for tonight, I will be deriving the formula for the area of an oblique triangle. What is an oblique triangle? There are two classifications of an oblique triangle. For a triangle to be oblique, it can be an acute triangle or an obtuse. For the acute triangle, the condition is that for it to be acute, all the angles must be less than 90 degrees. It is something like this, the figure here. Meaning, for it to be acute and falls under oblique, the sum of of angle A, angle B, and angle C should all be less than 90 degrees. Less than 90 degrees. Okay, less than. It can be considered an oblique triangle if all the angles are less than 90 degrees. And the next condition is an oblique triangle can also be an obtuse triangle. The condition should be that one of the angles should be greater than 90 degrees. One of the angles should be 90 degrees. Example of that will be this one. This is angle A, angle B, and angle C. Obviously, angle A, from the figure alone, it's greater than 90 degrees. And angle B and angle C, obviously, it's also, they are less than 90 degrees. The condition is that for it to be oblique and falls under obtuse, one of the angles should be greater than 90 degrees. Okay? So the figure for the obtuse triangle will be this, and the figure for the acute oblique triangle will be this. All the angles here are less than 90 degrees. For it to be obtuse, one of the angles should be greater than 90 degrees. So this one here is actually same as the figure we are solving. Okay. 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 Let's try to proceed. Actually, the area for an oblique triangle is the same as the area for a right triangle. Meaning to say, it should be 1/2 of the product of the total base area, base length times the height. The height of the triangles for the right triangle and oblique are different. It is just a representation. Meaning the area for an oblique triangle will be 1/2 the base length times its height. Okay, let's proceed. Okay. This is the total length of the base. I will designate that as letter B. And I will designate this portion here. Because actually, from this vertex here, I drop a vertical line. So meaning this is a perpendicular line. So if this is horizontal and this is vertical, okay, this should be 90 degrees and this should be 90 degrees. So meaning to say, after dropping the vertical line, which actually contains the vertical height, okay, what comes out is actually two right triangles. This should be the first right triangle, the one on the left, and the next right triangle is the one on the right. The one on the right, I will represent the base as simply x. For the meantime, we do not know x. So if this is x, this should be b minus x, because this is b, right? And this is height. So from our representation, h will be the altitude. The length of the base of the oblique triangle is B. It is this. And the area will just be simply capital letter A, and this represents area. Okay, let's proceed with the solution. The total area of the oblique triangle, the total area of this, will be area 1 plus area 2. For area 1, area 1 is a right triangle, right? You cover this one. So this should be the base, and this is the height. So by using our knowledge of the area for a right triangle, that is 1/2 of the base times height. Okay? Area 1 will be 1/2. Its base, considering the length, is b minus x. So this is b minus x. And its altitude is h. Okay? Plus area 2. Area 2. The one on the right. If you want to consider the one on the right, just cover the one on the left. So actually, you can see a right triangle. This is the height, and this is the base. Right? So area 2 will be 1/2 still. We are still using this one. It falls under a right triangle times the length of the base will be x, and its altitude is h. Okay? Let's try to simplify. A common factor 1/2, right? So we bring it out. The first one, we bring out this one. So what remains inside will be the product of h times b minus x. So this is h times b minus x. On the second one, we bring out 1/2. So what remains inside will be just simply the product of x times h. Right? Simplifying this one, this should be 1/2, open bracket. The product of h times b will be hb. And the product of h times minus x, a plus and a minus will be minus hx. This is plus, right? And they are both plus. So the product of two pluses will still be plus. So this should be plus hx. And luckily, this cancels with this, right? So if we try now to simplify, area for an oblique triangle will still be 1/2 of the total length of the base times height. Okay. It's still the same formula as for a right triangle. But this edge here is different from the edge of the oblique triangle, of course. This is just a general formula, meaning it is just a representation that for an oblique triangle, the area will still be 1/2 of the product of the base times height. Meaning, if you take the total area of this one, okay, it should be the product of the total 1/2 of this. 1/2 times base times height. So whatever the height, whatever the, what you call this, whatever value the given problem is, okay, try to compute for the value of h, to compute for the area. Okay, that's it. So for an oblique triangle, before we go for tonight, the area will still be the product of 1/2 times the total length of the base times height. Okay, good morning from Los Angeles. That's the area of an oblique triangle.